Hi, welcome to my video on solving polynomial equation using synthetic division. And this is part 2. The previous video was part 1. And again, we're solving a polynomial equation that's a x to the n, b x to the n minus 1, c x to the n minus 2, add on, plus plus, and k is the constant term. And the coefficients are integers. All a, b, c, and all the coefficients are integers or integral coefficients. So that means the roots are going to be integral roots because it's integers as the a, b, c, and k. And n is belong to the whole numbers. So this starts at, say, 4 and goes on down to when x to 0, which is the constant. And if you let a equal 1, then this equation becomes a is 1, so equation 1 is here, so it becomes the same as this, only there's a 1 in front. So that means that all the factors of k are the possible roots of the equation that fits this. Steps for solving equations above. Steps for solving this equation right here. This is what I do. Terms on the left side equal to 0, and I put them in descending order. And then I identify the number of roots by the highest power, whatever the highest exponent is here. That'll be the number of roots in the equation. And I always look for the GCF of x, take that out if there is an x common. Then I look at 1 as a root. The sum of the coefficients is 0. Then I see if there's grouping of terms. If I have 4 unlike terms, I'll look for the grouping. And these are ways that make it a little bit easier to find one of the roots. And if the synthetic division is needed, I will find all the possible roots by getting all the factors of k, which are the possible roots. Then I'll use Descartes' rule to find a number of possible positives, possible negatives, and possible imaginaries. And then I'll use synthetic division to find a root when the remainder is equal to 0. I'll do synthetic division on depressed equation to find another root when r is equal to 0 and repeat until the depressed equation is quadratic. And then I'll solve the quadratic equation by either factoring, completing the square, or quadratic formula. Normally, in this case, I would solve it by factoring if I can see it. And if not, I would use the quadratic formula every time. And a tip, when the first root is found by synthetic division, check that root again, because it could be there twice. It could be a double and also a triple root. So let's do some examples. And this is the order that I'll follow every time when I solve a polynomial equation. Let's do some problems. Again, pause the video and work these out. And again, here we go. Is it equal to 0? No. So descending order is x cubed plus 3x squared. Then the 2x comes over to become a minus. Minus 2 equals 0. So I have it in all the terms on the left equal to 0. I have it in descending order. And the highest exponent is 3. So we have 3 roots. 3 roots. Now, is the x a GCF? No, x is not in this term. Is 1 a root? If you add these up, 1 plus 3 is 4, negative 2 is negative 4. So the coefficients adds up to 0. So guaranteed, I have 1 as a root. I have a 1, a 3, a negative 2, negative 2. Draw a line, bring down your 1, multiply. 1, add 4, multiply 4, add 2, multiply 2, add, and I have a 0 remainder, which I knew because coefficients adds up to 0. 1 is guaranteed to be a root. So that means I have an equation x squared plus 4x plus 2 equals 0. That's the depressed equation. Remember, this is x cubed, x squared, x constant. So when you divide by x, that's a root of 1. So you're dividing by x plus 1. When you divide, it goes down by 1, so the cubic becomes a quadratic, x squared, x constant. And now, what factors of 2 will give you a 4? Well, I don't know, so I'll have to do a is 1, b is 4, and c is 2. So I'll use the quadratic formula x equals negative b plus or minus square root b squared minus 4ac all over 2a. And again, b is 4, so that negative of 4 is negative 4 plus or minus. B is 4, so that's a 4 squared minus 4. A is 1, B is 2, A is 1, A is 1, A, B, look what I did here, put a B there instead of, see, again, those little, what I call little brain errors, that's a C there. So C is 2, all over 2 times A is 1. And that gives me negative 4 plus or minus. And I'll work this out right here. So that's the square root of 4 squared is 16. And that's negative 4 times 2 is negative 8. So that's the square root of 8. 8 perfect square is, as a factor, is 4 times 2. So the square root of 4 is 2, root 2, all over 2. Negative 4 divided by 2 is negative 2. And 2 divided by 2 is 1. So, the 3 roots. So the roots are, and I have 1, and I have negative 2 plus root 2, and I have negative 2 minus root 2. And you'll notice that because I had 1 as a root right away, I automatically came up to the quadratic, so I didn't have to do any synthetic division. That trick is very important. Look for the 1. And notice, I just want to add here, the square root of 2 is, let's say 1.4 roughly, or so negative 2, add on root 2, that's 1.4. So that's a negative number there. And a negative 2 subtract root 2, that's a negative number. So there's 2 negative roots and 1 positive root, even though this root is irrational because of the root 2, but they are negative decimals that do not terminate or repeat. Okay, let's do number 2. We have it quartics, so we have it's in descend. Everything is to the left equal to 0. It's in descending order of 4, 3, 2, 1, 0. That's the constant, and there's x to the 4th, so there's 4 roots because the highest power is 4, so we have 4 roots. And I obey my order. There's no GCF, there's no x common in each term, so I can't take x out. Add up the coefficients, negative 8, negative 12, negative 13, plus 3 is negative 10. 1 is not a root because they do not add up to 0. There's more than 4 terms, so I can't do grouping. So that means I will look at the possible roots are all the factors of 8. 8 is 1 times 8 and 2 times 4, but I'm going to put them in order. 1 times 8, 2 times 4, so it's plus minus. So what I do is I put the plus minus outside instead of putting it for each one. So plus minus 1, plus minus 2, plus minus 4, plus minus 8. And what we have to do now is we're going to find out how many positive, negative roots, how many imaginary roots, and the total. Remember, the total is always 4. So let's check the equation. We got a plus to a minus, that's 1. We got a minus to a plus is 1. We got a plus to a minus is 1. And we got 2 minuses. So there's 3 possible positive roots or 1 possible. If you get 3, you take 2 away, you go down to 1. If you had 4 possible positives, then you would have 4. Take 2 away, you go down to 2. Take 2 away, you go to 0. So if you had 4, you get 4, 2, 0. Now let's check the number of negatives. So if you put a negative x in here, if you put negative x to the 4th power, you'll get a positive. If you put a negative x cubed, you get a negative of a negative as a positive. You put a negative x squared, you get a positive, so that's positive. Negative x here will give you a positive. Negative 4 times negative x, positive. And you have a negative 8. So you have only 1. So that means you have 3 positives, or 1, and you have 1 negative. So if you have, let's go back, you only have 1 negative. So if you have 3 positives and you have 1 negative, there's only 4 roots altogether, so you have no imaginaries. If you have 1 positive and you have 1 negative, then you'll have 2 imaginaries because the total has to be 4. So we're looking for either one of these. But what we do know that we do have a positive and we do have a negative. So what happens is that I know 1 is not a root, so let's check to see if 2 is a root. So what I'm doing now, I'm going to check. It could be 3 positive roots, so I'm going to check to see 1 is not a root, so let's check 2. So we got a 1, negative 1, 2, negative 4, negative 8. So 1, negative 1, 2, negative 4, negative 8. Draw a line, bring down your 1, multiply, 2, add, 1, multiply, 2, add, 4. You got an 8, add 4, 8. So 0, 0 remainder. So that means 2 is a root. So we have a depressed equation, which is 1, 1, 4, 4. Again, this is a quartic. So this is a quartic up here. So this is a cubic. X cubed, x squared, x constant. Now, we got 2. So we have to check the 4 and the 8. Now, we could go with checking the negatives, like a negative 1, negative 2, negative 4. But you're just taking a chance here and seeing. So let's check the 4. So we know 2 is a root because we got 0 remainder. Check the 4. Bring down to 1, multiply, 4. Add. You get 5. That gives us 20. Add 24. That gives us 96. And no. So now let's check to see if 8 is a root. Remember the possibles are 1, 2, 4, and 8. 1 is not a root because the sum wasn't 0. 2 is a root, 4 is not. So let's check 8 to see if 8 is a root. Bring down to 1, multiply, 8, add is 9. 8 9s are 72. So that's 76. 8 times 76 is not going to give you a negative 4. So 4 is not a root, 8 is not a root. So now we have to check for a negative root. So let's check with the first negative root is negative 1. So we got a depressed equation of 1, 1, 4, 4. Bring down to 1, multiply, negative 1, add 0, multiply, 0, add 4, multiply, negative 4, 0. Oh, that means we have negative 1 as a root. So the depressed equation is x squared plus 0x plus 4 equals 0. So that's the same as x squared plus 4 equals 0. So x squared equals negative 4. Square root of x squared is plus minus the square root of negative 4. X is equal to plus minus square root of 4 is 2. Because it's negative, you have an I. So we have the roots. Found them all. We got down to the quadratic equation, which is so we have a 2, and we have a negative 1, and we have 2i and a negative 2i. If you want to put them in order, go ahead. That's the 4 roots. Okay, let's continue. I try to have a variety of samples, working these out to make sure everything is okay, because you need to do variations. And again, we're solving this equation, and we have to have it all the terms on the left side equal to 0. So we have to move all the terms to the left side in descending order. So the x cubed goes next, make it a minus. The x squared goes next to make it a minus. So there's everything is to the left equal to 0. Descending order, cube, negative, square, negative. Notice now the first rule I have in descending order. Now the number of roots here there are 5 roots because of x to the 5. It's a quantix. And we got 5 roots. So x is common in every term, so I'll take x out. The smallest exponent is 2, so 2 is common to every term. So take the x squared out. X fifth divided by x squared is x cubed. Negative 2x to the 4th divided by x squared is x squared. And negative 7x cubed divided by x squared is x, negative 7x. And negative 4x squared divided by x squared. So notice your powers of x went down by 2 each time. So that means we have x squared equal to 0, or we have x cubed minus 2x squared minus 7x minus 4 equals 0. So if x squared is equal to 0, that means x is equal to 0. So notice even though x is 0 is a root, I want to emphasize there's 2 zeros here. That makes it a quantix to get. But if I say just x was 0, yes, 0 is a root, but I want to emphasize that there's 2 of them because of x squared. Now we want to solve this one as a cubic. So what we do is look at the possible roots. Now we know that here, so we have 3 roots. There's 2 gone, so there's 3 left. So there's 3 roots in this equation. And the possible roots are factors of 4. The factors of 4 are the possible roots. So there's 1, 2, and 4. 4 is 1 times 4 and 2 times 2. So plus minus 1, plus minus 2, plus minus 4. So now we check out to see the positive, negative, imaginary, and total. So positive, I have 1 change and no more changes. So I only have 1 change. So I only have 1 positive. So now I'm going to put the negative x in here. So if I put a negative x here and cube it, I'll get a negative. If I put a negative x here and square it, positive. So negative times a positive is a negative. If I put a negative x here, I'll get negative x times negative 7 is positive. And I got a negative 4. So I have no change here, 1 here, 1 here. So that gives me 2 changes or 0. So I have a 1. So I have 2 negatives. If I got 2 negatives, I have a total in this equation is 3. So I have no imaginaries. And if I have 2 negatives, I can also have 0 negatives. So if I have 0 negatives and I have 1 positive, then I have 2 imaginaries to give a total of 3. So I know I have 1 positive for sure, but I don't know if I got 2 negatives or 2 imaginaries. So let's go with, did the coefficients, now let's look at this equation. Did the coefficients add up to, we took the x out at the beginning. So since we took the x out at the beginning, then the x won't be common here. And I have, the coefficient doesn't add up to 0, so 1 is not a root. And it didn't add up to 0 up here, so 1 add up to 0 here. And we can do what we call grouping. So if you just take an x squared out of the first 2 here, you get x minus 2. But if you take a negative 1 out of here, you'll get a 7x plus 4. So grouping doesn't work because these 2 binomials are not the same. So that means I have to go and find a positive root. So 1 didn't work, so now I'm going to take this equation and work with a 2. So I got 1 didn't work, so now I'm going to try a 2 on this equation. So I have a 1, negative 2, negative 7, negative 4. Draw a line, bring down your 1, multiply 2, add 0, multiply 0, and you get, gotta just be careful here, negative 2, bring down 2, 0, 0, negative 7, and let's see, Okay, multiply negative 14, not going to work. So, not a factor. Didn't work. I thought it might have been working, but I thought I might have made an error, but that's negative 18, no. So now I'll try the same equation again, this one, because 2 didn't work, try 4. Bring down your 1, multiply, 4, add, 2, multiply, 8, add, 1, multiply, 4. Oh, we got it. 4 is a root. Now, we have a depressed equation, so it's x squared plus 2x plus 1 equals 0. So notice here we have an x cubed. So that means that if this is x cubed, x squared, x constant, this is x squared, x constant. So we got a cubic. Looks like everything is okay to factor because factors of 1 are 1 and 1. X squared is x and x. The product is positive 1. The sum is positive 2. So it's 2 positives. Multiply 1. Add 1 and 1, 2. So we got x plus 1 equals 0, or x plus 1 equals 0. So x is negative 1, x is negative 1. So we got 2 negative 1s. We have a 4, and we have 2 zeros. So the roots are 0, 0, 4, negative 1, negative 1. And again, check with your teacher. If you just say I got a root of 0, and I got a root of 4, and a root of negative 1. These 3 roots will give you this equation true. But I just want to emphasize that there's 2 zeros, and there's 2 negative 1s. Because if you just do this, you only got 1. That looks like you just got a cubic. But because you got 2 zeros and 2 negative 1s, then it makes it a degree of 5 quintics. Okay, that one is done. Let's try one more for a bit of practice. Try one more. Solve for x. And again, we had to get rid of the brackets by going x cubed plus 2x equals negative 3. Now we have to have descending order. So x cubed plus 2x plus 3 equals 0. And notice the coefficients. Let's see. We got equal to 0, descending order. Now let's check with the number of roots, x cubed. So there's 3 roots in this equation. And the possible roots are, let's go, plus minus. Factors of 3 are 1 and 3. So all the factors of 3 are possible roots of this equation. Okay, so let's check with the plus minus imaginary total. So notice that if you're checking, there's no change here. This equation, notice the x squared is missing, but that won't make any difference. So we got an x, no change, no change. So there's no positive roots in this, no positives. So now let's put a negative here. If I put a negative x here and cube it, I get a negative. If I put a negative x here and multiply, I'll get a negative. And that's a plus. So this is the negatives. So there's no change, there's one change. So I got one negative root, one possible negative root. So if I have no positives, one negative, and my total is 3 roots, it must mean I must have 2 imaginaries. No positives. Notice since all of these are positive numbers, it takes a negative number to give you a 0. So there's no positives, 1 negative, and 2 imaginaries. Okay, so let's go with, there's no positives, so let's try the negative 1. Negative 1 don't work, then we'll try negative 3. And again, there's no x common, no GCF. There's only 3 terms, so there's no grouping. So we'll try synthetic division on. But when I do synthetic division, I got to be careful because there's an x cubed plus 0x squared plus 2x plus 3. So when I do synthetic division, I got to go 1, I got to put the 0, I got to put the 2, and I have to put the 3. So in synthetic division, I have to put that 0 in for x squared. Now I draw a line, bring down to 1. Negative 1 times 1 is negative 1, add negative 1. Negative 1 times negative 1 is 2, gives me 4. Multiply negative 4, negative 1. No, negative 1 is not a root. Just negative 1. Okay, let's see if oh, yeah, look what I did. I multiplied negative 1 by negative 1 and said 2. Now, see, those little errors I make. Now I get a negative 3, and I get a 0. So that, I got to be always conscious of making some errors. So now if negative 1 didn't work, then I would have to check. So negative 1 is okay. I made the error. Negative 1 times negative 1 is 1. 2 plus 1 is 3. Negative 1 times, that's a negative 1 right there. So negative 1 times 3 is negative 3, gives you 0. Now I have x squared minus x plus 3 equals 0. Notice this is a x cubed, x squared, x constant. So this is an x squared. So a is 1, b is negative 1, c is 3. So x equals negative b plus or minus b squared 4ac all over 2a. So the goal is to get down to the quadratic, and I always use my quadratic formula if I can't factor. What factors of 3 is going to give me a 1? Well, I got to work them out. So b is negative 1, so it's the negative of a negative 1, plus or minus. b is negative 1. A is 1. C is 3. All over 2 times 1. The negative of a negative is positive. And I'm going to work this out up right here. So instead of so that's negative 1 squared is 1. And so that's 4 times 1 times 3, negative. So it's a negative 12. That gives me the square root of a negative 11. So that gives me the root of 11. Make that shorter there with an I. All over 2. So it gives me 1 divided by 2 plus or minus root 11 divided by 2 with an I. So we have, notice 3 roots. So the roots are, and we picked up the negative 1. We also got a half plus root 11 over 2i. And we have a half minus root 11 over 2i. Notice there's 1 negative root and 2 imaginaries to fit into this cubic equation. And that brings us to the end of solving by synthetic division. And notice the pattern that I developed. I always use that pattern every time I solve a polynomial equation. And if you like my video, click the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.